All right, good afternoon. 4 o'clock, go ahead and get started. So today we're going to talk a little bit about tankless water heaters. Specifically, we're going to get into Lochinvar's LTI model. We're going to talk about, so kind of a broad conversation today. Literally, we're going to talk a overview of the product itself, maybe some sizing and design considerations, some installation things that you want to look at. We'll get a little close and personal with it there. So I got the extra camera today, so we can stick it right in there. If you've got some questions, go ahead and ask them. Right now, I've got everybody muted. If you need to unmute yourself to ask your question, that's fine. If you want to throw it in the chat, you can do that as well. We'll go ahead and get those answered. But we talk about tankless water heaters, and one of the things that's important to kind of understand, there's some misunderstandings, if you will, about the efficiency of a tankless water heater versus a tank type water heater. BTU for BTU, they're the same. That means that if I heat 100 gallons of water, I will need the same net BTUs out of this guy here at 95% efficiency, net BTUs, as I would out of my tank type water heater. Maybe it's 80% efficiency. Now the difference becomes there are obviously my input BTUs are going to be different. That's where your efficiency savings are. So it's just important to understand that where the efficiency savings are. I don't produce hot water any differently as far as my BTU go. I burn gas just like I would in a tank type water heater. I burn it more efficiently over here. And then the second side of the efficiency saying or conversation really gets into, I don't have standby losses by having a tank here, but that changes my sizing. But at the end of the day, it's important to understand that. What's the difference? Where's the efficiency? The efficiency is obviously burner efficiency, and where that's going to be a much more efficient here. And I'll explain that in a few minutes why that works out that way. When we talk about, why would I want a tankless water heater? New construction. Obviously, this guy here takes up a lot less space than a tank type water heater is going to. And what you do get into, and that's where we want to look at our use, my over a length of time, if I'm talking about a continuous draw, I'm going to do a lot better generally with a tankless than I am going to with a tank type. Now, obviously, right up off the bat, my tank type, maybe it's got 40 gallons of water in, and I'm going to get some usage there that'll compensate a little bit for it. But if I get into a long draw, if I want to take a long shower, um, you know, kids can burn through a 40-gallon tank of hot water pretty quickly, whereas this is kind of going to stay along with them, especially if we're in a shower. Couple of pitfalls to watch out for, large tubs and those sort of things, where I might be drawing more than the unit's capacity to draw. So it's important to be aware of that. If I can generate, depending on the size of my water heater, my tankless water heater, 3, 4, 4.5 gallons of water a minute, and I turn a tub's faucet on that draws 7, I'm immediately going to run out of hot water and go to warm water. What's a solution for that? Well, the solution is, as the contractor, when you put that guy in, you put a flow restrictor on there and make sure that it can't overdraw. So if you're sizing one up, you put them in and you say, boy, the only time I'll run into a problem is somebody turns the tub spout on, you put a flow restrictor on. And when somebody does run that higher demand, all that's going to happen, we're going to see a little pullback on the pressure in there, but they're going to get that continuous amount of hot water that they're looking for. So you do that, that avoids that pitfall. And that pitfall sometimes is you can put 50 of them in an apartment building, one person calls, and they're like, oh, I got a problem with this one unit. Not really. Nobody else took a tub. And that's what we look at. So think of that as you're doing it. A lot of some of the other benefits of it, there's no standby loss. If it's not running, it's off. If I'm not using the hot water, so I go to work during the day, unit's off, my tank's not going cold, come back on. So those are the things that you would maybe look at when you're talking about, hey, what do I want? Do I want a tank type water heater, or do I want a tankless? So those are the things. Now, in some areas, especially here in New England, there's a pretty substantial rebate to put one of these in, and that might be a driving factor for you as well. So just some considerations that you have as you're doing it. Obviously, the venting becomes, things that you got to consider. This here is going to be a direct vent appliance. It's going to, depending on where you are in New York and Massachusetts, obviously not PVC, but in other communities, PVC, CPVC, polypropylene, stainless steel, those are your venting options there. You have common vent options for some of these. Up to 4 can be common vented together right out of the box. And it changes based on the size. They come with a cable, you connect them, they talk to each other. So that part of it's pretty simple. But let's go spend a little bit of time. We'll get a little closer to it and we'll talk about how does this thing actually work and how do we go from I'm sitting there on the wall doing nothing to now I'm going to make some hot water. So I'm going to jump us in a little closer to it, just so that we can kind of get a better eye on that and see what I'm talking about, because across the room it's a little difficult. So here we are. We're kind of up close with it right now. And, I want to be able to really talk about some of the different things. So what I'm going to do first is I'm going to remove the control panel out of the way. Just gives us a little better viewpoint of what's going on inside of there. I cheated a little bit. I already unplugged the control, so I could just pop it right off and take it. But there is just this single plug-in connector here, and it plugs in down on the board right there. So cheating a little bit, but you guys don't want to watch me struggle with it because that's exactly what it would be. Now, installation, let's talk a little bit about an installation consideration that's going to go into play, because one of the things we're going to kind of highlight over here, and just so you guys know, I have to look over my shoulder to see what I'm looking at when I'm pointing at it. So hopefully this all works out well today. When I'm down here, these are my dip switches. And in those, I'm actually going to give it some settings as far as altitude, vent legs, those sort of things that I want to be able to do. So that's going to be there, and that's going to be on your initial installation. Now, plan your venting out when you first get started so that you don't box yourself into a corner. They do limit the number of 90s you can use. For most of these, it's no more than 5 90s, regardless of really where your vent run is. And you're going to have to select the length of your vent run over here on your dip switches. There it is. Find my hand somewhere. So those are considerations you'll have to make, and probably do it before you get too far into it. What's another thing that we might want to look at? So what is our, when I start looking at my gas piping. So make sure that we got adequate gas supply pressure. So really the difference between that tank type and that tankless is going to be the amount of gas I use in a period of time. And so like I said earlier, if I heat 100 gallons of water, I use the same BTUs. I'm just going to use it a lot faster here because I produce it quickly. And that's what I'm doing. My recovery rate is fast. Make sure that your meter's large enough. This is a 199,000 BTU water heater. If I have a furnace in the house, maybe I've got a 140,000 BTU furnace, I put a 199,000 BTU tankless water heater in, I'm now hitting that 340,000 BTU mark. Is my gas meter outside large enough to provide that sort of that's sort of gas delivery? And those are sort of the things that can kind of, one of the pitfalls that you could run into. So certainly make sure that you have that there. Minimum gas pipe size for this unit is 3/4 of an inch. And again, you're going to have to measure out the length, how far your gas pipe is, and get your equivalent length. So let's a little bit of operational stuff here, and hopefully this is there's a little wiring in the way, but this is where my water comes into the unit right here. Now, right there, that's my flow sensor, and I'll be looking for a 1/2 gallon of water a minute. As my water moves up through the pipe, it actually kind of shows up over here. This is where I'm coming up and in, and this pipe is going to take me up into my secondary heat exchanger first. And what that's doing is I'm going to grab whatever energy I can out of here before this goes out in the exhaust. I'm then going to come finish through the secondary heat exchanger, come back down here into the primary heat exchanger, and I'm directly over my burner. So I'm in theory heating this first, grabbing what's left, on my way out the door, trying to cool down those gases. Now, remove this camera just a little bit here. I want to show you guys this bypass valve. It's kind of important in there. So tucked right back in there, hopefully you guys can see that black valve there. Now that's the bypass valve. And what that's doing is it can divert into the outlet water some cold water. And what it's looking at is the outlet water temperature, and it can influence the outlet water temperature if it's got to cool it down by using that bypass valve to divert some of the basically the cold incoming water, mixing it, almost working like a mixing valve right there inside the unit. As we look around, you see a lot of these yellow wires here, these little resistors. So this here is actually my freeze protection. Here, I've got a sensor. Mount them right up here in the top here. This is my freeze sensor. And if I'm sensing that, I actually can heat the pipes within the unit and do some freeze protection there. So that's what we have there. We got a little freeze protection built into it. Now let's get down here into the guts and the good stuff of it right here. If you were taking it apart, I can tell you that there's two tools that are required. You need a long nose, about an 8-inch Phillips head screwdriver, and you need a pair of pliers is all you need to take it apart. It's a ton of parts when you take it apart, so I'm not going to take it apart today. I'll probably get in trouble since I basically borrowed this one. So in here, in behind this thing are my gas valves. There's actually 5 of them in this particular unit. There are 5 gas valves that are down here. It's all kind of activated down here on this side. And then up here is this is my burner tray, and I feed into it. It's my flame sensing, and this is my igniter on this side. So sequence of operation. I get that half a gallon of water that comes through in here, turns everything on. I'm going to have my fan is going to turn on, and then I'm going to spark, and I'm going to open my gas valves, whichever one I'm looking at that point in time, to really kind of, and then I can modulate those valves up and down to match my load. And that's how I'm going to modulate to kind of meet a small load, large load, whatever. One of the options for this unit, as we're talking about what causes it to turn on, is you can order it with a pump built in, a recirc pump. This particular model doesn't have that recirc pump built in. If it did, it sits right behind this. Make sure I'm in the right side. There we go. Again, literally no coordination there. So as I tuck in there, behind there, I'll have a recirc pump. Now that works on a timer. When it turns on, it's also going to trigger the unit to fire. So one of two things: I got a half a gallon of flow, or I have the thing on there that's going to my recirc pump is going to trigger that. So that's where we're looking at within there. If I'm doing a tear down service on it, I'm actually removing this plate with my gas valves on it, and then my burner tray is going to pull out from there. A couple of points that may be important, on the troubleshooting end of it for those technicians that are here, is this port right here. Now what this port here is, I can actually look at pressure within the heat exchanger. Do I have a scenario where I'm over length? Maybe I've got an obstruction or whatever, and I can actually take my pressure using a manometer within there. So that's a spot, if you're running through some tech support issues, that's really where we would go to right there, is adjusting or at least testing right there. But again, it's fairly simple and fairly straightforward. Everything's got a lot of clips on it. When you pull it out, I see that John is asking about, do we have a replaceable actuator on that? Yes, we do, John. It's right on the top here. And I know you guys can't really, it looks great in my space because I have really good lighting, but it's right in there where my hand is. I'll wave at you. And that's where my actuator is. It's held on there just by 2 screws and a clip. So it pops off pretty easily. So Ray's asking the question, do these provide domestic hot water and space heating model? So Ray, these are a specific domestic hot water model. One of the uses though that is allowed when we talk about space heating, especially here in the Commonwealth of Massachusetts, is I could actually tie this in to an air handler and actually use the potable water to heat an air handler and to provide domestic hot water for the space. It does mix them, but it's done frequently. And in fact, there's thousands of tank type water heaters installed in this manner and throughout the Commonwealth. And this is an option for a replacement of it. And it's something that you can use for that. So it's again, it's fairly simple, fairly straightforward. It does provide you a whole heck of a lot of options. You can get into remote controls for it. You know, distance. They do have indoor and outdoor versions of this. I do not recommend an outdoor model here in New England. You're probably living on the edge if you do that, or maybe it's in your, you know, your second home, your summer home. Now we have a couple other things over here that I want to touch on, and really it's our condensate drain that comes out here, and I can drain my condensate out the bottom. Get you guys just a little better angle on that. And these are my condensate drains. So I'm getting my extra condensate out of here. This is we're going to wring every bit of energy we can. We're lowering the flue temperatures as we get that condensate. We're going to drain it down and out there. And you see again, we have freeze protection. The other thing that's in here, and I want to kind of get you guys a look in at it. Again, it's behind some of the piping. It's a little tougher view, but right back here, you guys see that tube that's in there behind my big hands? There it is. So for those of you guys that are in New Hampshire, Maine, and we have cabins, we have camps, we have those sort of things, that's a drain tube. So if I'm shutting and draining down the hot water system for the winter time, underneath I've actually can open that up and I'm going to be able to drain down this boiler, because that's the low point that'll help us drain it through. The other valve's gonna, or the other pipe is gonna drain it out the bottom. And if you didn't put a service kit on at the bottom on the cold and hot water, that's okay, because they added a couple little ports to be able to drain it and not service it, but definitely able to drain it down through there. Let me move this guy back out of the way so I don't trip on it. There we go. So move around. So it's a fairly simple install. Does have a service switch on there, that off-on switch that you have right there. But remember, it's not really a service switch because I still have power inside the cabinet, even if I shut that off. So we should always put something on the outside to take care of it. I think I did give you guys a little view of the freeze stat that's up here, right at the intake side. And that's where the intake is. So if all of a sudden we've got freezing temperatures in there, we're going to turn those heaters on, and we're going to prevent this guy from freezing. Now, just circle back again to the two heat exchangers, because it is a little confusing in the fact that we go into the secondary first and we go into the primary last. But my hottest flame is really here as I'm heating it up. And then when I come across here, I'm just taking that last little bit of energy out, whatever I can. And that's where I'm going to bring these flue temperatures down into that condensing range. And as the flue temperatures come down, there's a couple of things. One is I can go and vent in plastic pipe, but I'm also getting that additional efficiency. When you get into a non-condensing model, basically I don't have this. Okay, I don't have that secondary heat exchanger. All my heat transfer takes place here, and then all that extra energy, you know, is going out into the exhaust. So it's a nice ability to kind of grab and steal that extra energy and make the unit more efficient. So that's what that's doing for us there. Over temp switch right there. We have on the unit, and that's in the heat exchanger there. We have several other water sensors, temperature sensors here. We've got a couple down below as it's getting ready to go out. And that's how it's able to use that bypass valve to temper the water temperature going out to the unit to make sure that we're not sending out a temperature that's too hot. And the unit's doing it thatself. And it modulates not only that bypass valve there, but it's really modulating the burners through the gas valves here to really hit where we want to for that water temperature going out. One of the things about it is the unit's been around quite a long time, and it's although it looks busy, it's actually pretty darn simple. And that's what's nice about it. You hang them on the wall, you pipe them up, and off they go. There's not a lot that you're going to do to them. If you're in an area where with hard water, you want to look at, you know, if you use what is a product protector, which, you know, Lochinvar offers through that. And what that does is it's really a process of causing the scale to be inert. And the scale is inert as it passes through the unit and it doesn't stick. And what that does is it prevents scaling up within the heat exchanger. which also prevents me having to go in there and descale the heat exchanger. The thing about copper and descaling is it's not something you want to do a lot of because it does start to wear on it. And even though we're using this commercial grade copper heat exchanger, using a product protector is going to do a great job of keeping that free of scale buildup, because it won't stick. It just flies really right through the unit. And we can do that because it's a tankless unit. If I had a tank type unit, what would happen is, yeah, I might make it inert, but it's going to sit in my tank and it settles to the bottom. And then I get that buildup. And as I get buildup of scale inside my tank, what happens is I reduce the efficiency of my unit. Because I don't get the scale buildup, the efficiency from day one will be the same efficiency a year, 2, 3, 4 years down, because I'm still transferring the same amount of energy without running into the insulating factor, if you will, of that scale and having to heat through it. So kind of enjoying, just so you guys know, I'm kind of enjoying sticking my hand in and out of there and watching it over there. It's a little strange. Surreal, I think, is the word I'm looking for. So again, simple process that it goes through. And even if you get into the manual, the majority of the manual is really talking about the venting process and not as much anything else that you get into. Now, accessories that are included with it, not a lot on an indoor model. On an exterior model, an outdoor model, you're going to get that temperature controller. But like I said, I'd be really cautious of using one of those. In my dip switches, I'm really looking at the length of my venting and my altitude. Where would we see altitude models? Brad up in Vermont might be running into that with somebody that's at a higher altitude, and we would want to adjust those settings. And then our dip switch settings are really getting into our vent lengths. On 4-inch venting, we can take this up to 100 feet. On 3-inch venting, we're going to limit to 70 feet. So important to keep that in. And again, no more than 5 elbows. And those are the things that you can, run into. So John, I see you're asking there about the a water softener. So interestingly, so we actually have some pretty soft water here in New England in a lot of cases. And that actually attacks within the piping. So we try to stay away from creating overly soft water. And then water softeners tend to be salt. So again, it's another consideration to have as we're doing that through there. But generally, New England doesn't have hard water that requires softening, even though we tend to see it a lot. I'm working with a project right now, and they've had issues because their water's too soft, and the water treatment company came in and offered a water softener as an answer. So
Hey,
kind of
Rob,
going the wrong direction. Yeah,
Don Moody also asked if the bypass valve has a replaceable actuator.
I did. I pointed that out, Mike. It's got the screws and the clip on the top.
Gotcha.
I'm on that there. It's tucked in behind there. It's a little tight, but I can get my hand in there and I can get that out as needed. Mark, he sent it on the side thing. Domestic hot water mixing valves. I'm a fan of a domestic hot water mixing valve anytime we're using something like this. It's not actually required in this unit from the manufacturer. It's never a bad idea, but it's not actually required because we have that internal bypass valve in there that is adjusting for that. So it's a little different animal. One of the things, and Mike's put it there in the chat, is the Noble combi, and it works a little different because it's doing space heating and domestic hot water, and it can switch back and forth. And that's where you get into, hey, I really want to have that domestic that mixing valve just in case I kind of spike in my temperatures as I'm going off or as I'm shifting. When we get into gas supply pressures, 8 inches the minimum on propane, 4 inches the minimum on natural gas. On natural gas, a little different here. 10.5 inches of water column is going to be our maximum for our natural gas, but 14 inches will be our maximum on propane. And the propane conversion is a bunch of little orifices are going to go in here into the burners to make that adjustment to what's happening in there. So while it looks busy in here, if we were actually pulling this whole thing apart, it's about 20 minutes and I could have everything out of the entire cabinet. There's not much to it. One reminder or one piece of advice I would give, if you were taking it apart, take a picture of the wires and where they connect right here. It's just going to make it easier when you go to put them back in. Obviously the Molex plugs, you're going to find the connection, but it's a lot easier if I'm looking at something that says, hey, this is the one that goes here or there. One of the nice things that comes with the unit in its manual is a real nice flow chart that kind of goes here, and it shows you really the direction of flow of how everything is moving and going through the unit. Indoor models actually all come with a grounded plug on them, so it's legitimately plug and play. A outdoor model, you're going to have to wire that one yourself, and that gets into grounding and outdoor GFIs and stuff like that. That's why that's not included with there. Just make sure you don't connect it to an extension cord and run it across your pool while you're at it. So not a lot here. Really don't want to keep circling around and beating the dead horse. Anybody have any questions other than kind of what we've covered so far?